Okay, we're going to do some vector board battle problems here. We have 4 problems we're going to do in the physics manual. At least when I made this video, it was on page 8. We're going to do 131 through 134. Okay, here we go. 131. It says that there's a plane flies at 100 miles per hour on a 130-degree heading. Okay, so I'm going to draw my grid. And 130 would be 90 and then 40 more, so it would be like something like this. Okay, and we're going to say it's 100, and I like to surround it with its angles, so this is 40 degrees, and of course this one would be 50. Okay, so I got my first vector on there. Then it says there's a 50 mile per hour wind on a 70-degree heading. Okay, so to keep this straight, it can be confusing if you don't do this. I come down to the head of this vector because I'm going to add the next vector onto it. And I'm going to put a new grid right on there so I know how to add my next vector on. The next vector is 50 miles per hour, so I'm going to make it half as long as this 100. And it's going to be on 70-degree heading, which means 70 degrees from north. So I'm going to go in like this. That's 50. And I know that this is 70 degrees. Okay? Now, so see, this is helpful if you put all these angles on here, because if this is 50 degrees here, then this alternate interior angle here, so you got 2 parallel lines, right? Cut by a transversal. So if this is 50, this is 50, and that means this entire angle here is 120. I'll just change that, 120. Okay? So I want to find the resultant vector, and the resultant vector goes from the tail of the first to the head of the last. I just totally made it curved. Okay, it doesn't matter. It's good enough. Okay, the math will help us get it right. So I have side, angle, side, and I can use law of cosine. So I'm going to do this vector, we'll call it vector v. Vector squared equals 100 squared plus 50 squared minus 2 times 100 times 50 times the cosine of 120. And I can figure out at least the speed of that particular plane. So 100 squared plus 50 squared minus 2 times 100 times 50 times 120 cosine equals, and then I have to do square root, and I get 132 miles per hour. That's the speed. Now, where is it? So I need to figure out where is this vector on this grid. Okay? So the way to do that usually is to figure out an angle in your triangle. I'm going to figure out this angle right in here first. And I can use law of sine. So sine of that angle over its opposite side, which was 50, would equal the sine of some other angle. We'll use 120 because it's the only one we have, over its opposite side, which we just figured out was 132. So I can cross multiply and divide. 120 sine times 50 divided by 132. And then I'll do inverse sine. And I get an angle in here of 19.1. Now, how do I figure out where this vector is, though, from this grid? Well, I want to do from north. So I want to go around from here down to there. How do I do that? Well, I know it's 40 from here up to here, right? And it's 19.1 in here. Okay? So I could take the 40, or I guess I know this is a 90 plus 40. So this is 130 all the way down to here, right? 130 degrees. So I can take 130 minus the 19.1, and I'd have it, right? 130 minus 19.1, and I get at 111 degrees from north. 132 miles per hour at 111 degrees from north. That's your first problem. Hopefully you got that right. Make sure you go board battle these problems and then come check the video, because it's not going to help you. You're going to think it's really easy if you're just watching the problem. So you need to join in on the struggle for a while. Okay, let's look at 1.32. It says a pilot wants to fly a plane at a velocity of 500 kilometers per hour east. Okay, we're going to assume this pilot's smart, and we know he needs to go east at 500, so he's going to do everything he can to make sure that happens. So he's going to check the forecast, and he's going to see that there's a wind blowing south. So how's he going to do that? Well, that means then that what they gave here, the 500, this 500 going east, this is actually a resultant vector. This is what we want to have as the resultant. We want to result in this. So how would I do this? Well, that means if I know there's a wind going south, that means the pilot's going to actually have to head his plane up more like this, right? And then we add on the wind to that, which would go down like this, and the wind is 75. So in this problem, it's really an easy problem, but the trick is, sometimes I give you the resultant, what we want to accomplish, and you're trying to figure out like one of the components, like this. This is one of the components. The resultant doesn't have to be the longest side, by the way. So in this case, this component is going to be the longest side. And this is a right triangle because this is going straight east and this is going straight south. So I know this is a 90 degree here. And I can figure out the velocity here very easily. I can just do Pythagoras Theorem, shortened theorem, 500 squared plus 75 squared equals, and I do the square root, and I get 506 kilometers per hour. That's the speed. And what's the direction? Well, this is my grid right here. I'd like to figure out eventually this angle here, right? Because this is the angle from north to where my vector is. So what might be good is this angle here is the same as this angle here, right? They're alternate interior angles. So I'm going to try to figure out this angle, and then I'll have my answer. So how do I get this angle? Well, I have the opposite, I have the adjacent side. So tangent of that angle would equal 500 over 75. By the way, if you figured out this angle, that's totally fine too. You would just have to subtract it from 90. Okay, I'm going to figure out this angle because that actually would be my answer. It's the same as this right here. So 500 divided by 75 equals, and then inverse tangent, and I get at 81.5 degrees from north. So this angle here was this angle here, and now I have my angle from north. QED that one. Okay. Hopefully you got that one right. All right, next one is a bridge problem. It's our first bridge problem. So we have to learn how to do some bridge problems. So on bridge problems, not bridge problems, boat problems, we have a river. Okay, and the key to understanding this is rivers flow down, right? Water goes down. So I don't know which direction the river goes. I don't know if it's going north, south, east, west. I don't know the direction it's going. So we don't use the standard bearing directions on this. On rivers, what you do is you draw a straight across. Okay, you draw a straight across. And I shouldn't have drawn actually as a vector, I suppose. But anyway, the straight across is 0 degrees. And then you can go so many degrees upstream, or you can go so many degrees downstream. And that's what uses our label. Degrees downstream or degrees upstream. We don't do north, south, east, west stuff on rivers. Okay. What's this problem say? It says a boat needs to cross the river to a dock that is 19 degrees upstream. All right. So here's the boat. Here's the boat. Right over here. And here we'll say here's the dock. I'm going to exaggerate this a little bit. And we need to go from the boat to the dock. That's what we have to do. So this again is going to be our resultant. We need to get to the dock, and the dock is 19 degrees upstream. Okay, how are we going to get to the dock upstream if we know the river's flowing? Okay, well, we're going to have to actually go at a heading something a little higher, right? And then to that, we will add our river. Our river goes down. And the river is flowing at 3.2. And it says, if an observer on the riverbank clocks the boat at 15 meters per second. So if someone's standing over here, they have a radar gun on the boat, and it says, hey, that boat's going 15 meters per second. Which one of these is that? Is it this one, or is it this one? Okay. Well, it would be this one. Because this is what's actually, this is what the person is seeing happen, going from here to the dock. Okay, so your speedometer on your boat might read something a lot higher because you're doing this. You're trying to go against the river. But the river's adding, taking away from it, and the speedometer would actually read whatever, or not speedometer, the radar gun would read what this one is. So the 15 actually goes on this. We're going to actually try to figure out what the velocity of the boat needs to be to make this happen. So I have a side and I have a side here. I'd really like to get this angle in here, and I don't know if you can see how to get that, but if I drew in a parallel line here to this, that's 19, this would be 19, and this is 90 up here, so this angle in here is 109 degrees. And I can use Pythagoras Theorem. So I'm going to do 15 squared plus 3.2 squared minus 2 times 15 times 3.2 times cosine of 109. And then I'll have to take the square root of that whole thing. I'll do that for you real quick. 15 squared plus 3.2 squared minus 2 times 15 times 3.2 times 119. Oh, rats. Wrong angle. 15 squared plus 3.2 squared minus 2 times 15 times 3.2 times 109 cosine equals square root. Wow, a lot of math, and I don't have a fancy calculator, so I couldn't just delete. I get 16.3 meters per second is how fast the speedometer would be reading. See, I'm going against the river, so I'll end up only going 15 meters per second right here. Okay, I need to figure out where I am on this river. So what I want to do is I want to figure out this angle here, theta, and I can use law of sines there. Sine of that angle over the opposite side, 3.2, equals sine of 109 over 16.3, what I just figured out. Okay, so 109 sine times 3.2 divided by 16.3 equals inverse sine, and I get a 10.6 degrees. So this is like 10.6 degrees. So how do I decide where I am? Well, remember, on river problems, we go from the straight across. Obviously, I'm upstream. How far upstream is this vector? It's this far upstream, and what is that? That's 19 plus 10.6. 19 plus 10.6, and basically it's like 30 degrees upstream. So we're going to go 16.3 meters per second at 30 degrees upstream is our heading of our boat to try to make it to the dock. Okay, one more problem, and this one's a doozy. 1.34. Okay, so we have 3 vectors we're going to add together here. So this could be tricky. So what we really want to do is we just want to add 2 vectors together first, get a resultant, and then add the 3rd vector onto that. That'll be the easiest way to do it. So we're going to start with a grid here. And we have 100 units at 63 degrees south of west. So 63 degrees, something in here, we're going to put 100. And this was 63 degrees south of west. So this would be 27, right? Yeah, 27 degrees there. I'm going to put my angles on this. Okay, we're going to add vector B to this. 198, that's like 200. That's almost twice as long. At 40 degrees south of east. So I'm going to draw a new grid here. Okay. Oh, this is not going to work. My drawing is terrible. I'm going to be off the screen. I need to redo this. All right. Sorry. We're going to redo it. Because I'm going to come clear down here off the screen. So didn't think this through. All right. So I'm going to start over here again. I'm going to come up here and draw my grid up here. And so I'm going to come in like this. 100. That was 63. That was 27. Didn't do that very good either, did I? And so now I'm going to come here and draw a grid, and I'm going to come 40 degrees south of east. So I'm going to come like this. I'm going to draw a big long one. Probably should have even went further. 200. And this is 40. And of course this would be then 50. Let's see. This angle here would be 63, right? Opposite of this. And this would be 27. Okay, so I'm going to get the resultant of this. So I'm going to go from here to there. I want to find this resultant. And that's good because I have 63 and 40. This is 103 degrees, my angle in the middle. And so I can use Pythagoras Theorem. So I'm going to do 100 squared plus 200 squared minus 2 times 100 times... Oh, that's not actually 200. It's 198. I better make that correct. Minus 2 times 100 times 198 times cosine of 103, square root that. And this is 198 instead. Okay, so I have, let's see, 100 squared plus 198 squared minus 2 times 100 times 198 times 103 cosine equals square root, and I get 241. This is 241, and I got to figure out where this is. So I want to figure out this one here is coming from down here. So I'm going to figure out where it is on this grid. I'm going to try to figure out this angle here. I think might be helpful, and I can do that. I can do sine of that angle over 198 equals the sine of 103 over 241. So 103 sine times 198 equals, divided by 241 equals inverse sine. And I get this whole angle here is 53.2. Okay, so I probably should be a whole lot further over here than I drew it, but you let your math do the work. So I know it's 53.2, this whole angle, so I know it's 27 from here to here. So I'm going to take 53.2 minus the 27, and I know that this angle in here, although it looks too small, is 26.2. Okay. All right. So I'm going to redraw that on the next page. So let's see. I'm going to try to remember that. 241 at 26.2. So I'm going to draw a grid. I'm going to do, I'll draw it a little bit better now. 241, is that what it was? 241, yes. At, what was the angle? 26.2 degrees. That's the angle in here is 26.2 degrees. Okay. Good, that's what we got. And we're going to add in our third vector. By the way, this is 63.8 degrees. So on here, I'm going to draw in the third vector. And the third vector is vector C. It's 150 units, so not as long as 241, at 20 degrees north of east. So north of east, I'm going to come in here like this. I'll draw a little vector here, 150. This is 20. So this would be 70. What is this angle here? It would be the opposite of this one, so it would be 26.2, which means this angle in the middle here is 96.2. 96.2 degrees. Okay, so my resultant goes from here down to here, and I have side angle side, so I have 241 squared plus 150 squared minus 2 times 241 times 150 times the cosine of 96.2. Boy, I really hope I'm doing this problem right. Hope I didn't mess up somewhere. Square root. So we'll do that. 241 squared plus 150 squared minus 2 times 241 times 150 times 96.2 cosine equals square root, and I get a final velocity or final speed of 297. These are just units. I don't know what they are. Units. Okay. and I got to figure out where it is. So I'm going to figure out this angle over here. Sine of that angle over the opposite side, 150, would equal the sine of 96.2 over 297. So 96.2 sine times 150 divided by 297, inverse sine. This angle in here in the middle is 30.1. And I want to figure out where is this vector from north all the way here. Okay, so this is 30.1 and this is 26.2. So I could add those two together and take it from 180. So 180 minus 30.1 minus 26.2 equals, I get at basically 124 degrees. Woo! That was a doozy of a problem right there. QED that. Pretty sure that's right. 297 units at 124 degrees from north is the vector resultant from all three of those vectors being added together. Okay, hopefully you got that figured out. There is a much easier way to do vectors. I punished you to make you go through this challenging way first to learn this way. And then later we'll use a vector component method. And we'll do this whole problem over again using vector components just to prove to you how easy the new method is. So hopefully you got all those board battles correct. And I'll see you soon.